Welcome to today's Explainer. We're jumping right into a fascinating, frankly, critical topic that is completely reshaping enterprise AI security, and that is RAG's expanding attack surface. Now, if you've been working with large language models at all, you already know Retrieval-Augmented Generation, or RAG, is literally everywhere. It's the absolute backbone of practical AI systems right now. But with all this incredible power comes a genuinely surprising, hidden vulnerability that we really need to unpack today.
So, let's kick things off with a question that might honestly keep you up at night. What if your most trusted AI assistant is secretly taking orders from a hacker? I mean, we tend to think that our internal lockdown enterprise AI systems are inherently safe from outside manipulation, right? Well, today, we're going to completely shatter that illusion and look at exactly how these systems can be weaponized against us.
To ground this abstract threat into something a bit more familiar, I love this brilliant analogy from a cybersecurity discussion by a user named ScamScanUSA. They said, prompt injection through documents is basically the new macro malware, just for LLM pipelines. Remember how malicious macros used to hide in seemingly innocent Word documents? It's kind of like that, but the attack vector isn't executable code anymore. It's just natural language, hidden right in plain sight. Which brings us to this simple, undeniable truth. In the era of RAG, all input is untrusted, period. Developers, security teams, everyone needs a fundamental mindset shift regarding how we view document ingestion pipelines. You literally can no longer assume a document is safe just because it doesn't trigger your standard malware scanner.
Section 1. The AI Knowledge Revolution. Before we look at how to break these systems, let's do a really quick refresher on what makes them so powerful in the first place. Retrieval-Augmented Generation, or RAG, is basically a framework that integrates external knowledge into an LLM's generation process at inference time. Why does this matter so much? Because standard LLMs are totally boxed in by static training data, and let's face it, they love to hallucinate facts. RAG swooped in and solved this by acting as a dynamic bridge between the language model's reasoning engine and your actual real-world enterprise data. It improves factual grounding and relevance immensely.
And this foundational concept, it has evolved incredibly fast into a whole ecosystem of architectures. We started with vanilla RAG, your basic search and summarize pipeline. But look at how it's grown. We now have corrective RAG, which actively double-checks its own answers. We have graph RAG, capturing complex relationships between entities. And right at the cutting edge, we're seeing agentic RAG, where autonomous agents dynamically decide when to retrieve and exactly how to reason over massive enterprise datasets. These systems are essentially becoming the cognitive infrastructure of the enterprise.
Section 2. The Security Blind Spot. Because all this amazing capability to read and reason over external documents, it actually introduces a terrifying Trojan horse vulnerability.
We are honestly living under an illusion of safety right now. Just take a look at the left side here, your chat interface. It's secured with authentication, it's highly monitored, and it's heavily locked down against direct user manipulation. But now look at the right side, the document ingestion pipeline. According to security experts, this is very often treated as a trusted internal network. Unstructured uploads, third-party PDFs, API feeds, they're just left wide open to exploitation. It's like enterprises are spending millions heavily guarding the front door while leaving the loading dock completely unmonitored. So how do attackers actually sneak in through that loading dock? Well, they use invisible threats, things like PDF active content, hidden Unicode layers, or literally just putting white text on a white background. They'll tuck instructions into metadata fields and comment blocks. And the craziest part? These aren't malicious scripts. They are literally just text. A standard antivirus scanner will look at a file like this, say, "Looks clean to me," and just wave it right through.
Section 3. Indirect Prompt Injections. This is the specific, highly dangerous exploit taking full advantage of that massive blind spot.
An indirect prompt injection is an attack where malicious instructions are hidden in seemingly benign external data. It steers the LLM's behavior when retrieved, even if it's completely imperceptible to a human reader. And guys, this isn't just some theoretical lab concept. The OASP Gen I Top 10 lists prompt injection as their absolute #1 vulnerability for 2025, tagged as LLM01. And here's the real kicker. The research explicitly notes that RAG actually facilitates this vulnerability by indiscriminately feeding external text directly into the model's context window.
Let's make sure we're super clear on the difference here. On the left, we have direct prompt injection. That's when a user goes in and types a malicious command directly into the chat prompt, trying to jailbreak the model. But on the right, Indirect prompt injection. Here, the user is entirely innocent. They're just asking a completely benign question. But an attacker has hidden a command in a third-party PDF. The AI retrieves that PDF to help answer the question, and suddenly your super helpful assistant becomes an unwitting accomplice, just because it read the wrong file.
Section 4. Anatomy of an attack. Let's trace exactly how this silent heist plays out in a production RAG system.
You're gonna want to pay close attention to this sequence because it is chillingly simple. Step 1. The attacker poisons a totally normal-looking PDF with hidden instructions. Say, a resume or a vendor invoice. Step 2. Your automated enterprise RAG system ingests and indexes that PDF into its vector database, completely unaware anything is wrong. Step 3. A legitimate user queries the AI assistant, asking something totally normal like, hey, can you summarize this vendor's invoices? And then, step 4, the AI retrieves that context, reads the hidden command right alongside the invoice data, and boom, it executes the malicious action. Maybe it exfiltrates private conversation data to an external URL. It happens silently, it's efficient, and often nobody notices a thing.
Because the core issue staring us in the face is this. The text extractor sees clean content, but the LLM sees instructions. Your parsing software has absolutely no idea it's handling a weaponized document. It just extracts the text and blindly hands the keys over to the reasoning engine, an engine that has been explicitly trained to faithfully follow whatever instructions it finds.
Section 5. Building defense in depth. Because once you understand this vulnerability, you can actually start building architectural mitigations to lock those gates back up.
Since we can no longer implicitly trust the ingestion pipeline, here's what defense in depth actually looks like in practice. First, you absolutely must strip and normalize content before ingestion. Flatten those layers, strip out hidden text. Second, implement a sandboxed processing layer for untrusted files. Third, establish trust tiers. Basically, official company policies should mathematically outrank a random community wiki in your retrieval weighting. Fourth, add rigorous output validation to ensure the model isn't secretly leaking data. And finally, utilize human-in-the-loop approvals for any external actions. If the AI is trying to send emails or make API calls, a human needs to hit approve.
Mature next-gen RAG architectures handle these vulnerabilities by mapping specific failure modes directly to concrete engineering mitigations. If you have a retrieval gap, you use hybrid search. If you're dealing with context poisoning, you deploy anomaly detection for documents that suspiciously match every single query. And to combat our main villain today, indirect prompt injection, the engineering mitigation for that is instruction segregation, usually using XML tagging.
Let's zoom in on instruction segregation for a second, because it's a real game changer. This is a technique where you use strict XML tags to literally separate the user's instructions from the retrieved context. By mathematically isolating the retrieved text inside these specific tags, you train and force the model to ignore any commands found within the data itself. It mechanically prevents the LLM from confusing a hidden attacker command with the user's legitimate, safe prompt. And this concept of filtering builds directly into what we call corrective RAG, or CRAG. Just take a look at step 2 here. Instead of just handing raw data straight to the generator, a lightweight evaluator model steps in like a bouncer. It grades the relevance and safety of the documents. If it detects a poisoned or poor quality document, the system triggers a corrective action. It essentially hits an automated panic button. So only safe, clean, verified context is ever passed to your expensive generation model.
We've definitely covered a lot of ground today about the hidden dangers in the data we feed our models. So I want to leave you with this final, provocative thought to chew on. Your chat interface is secure, for sure. But what exactly is your AI reading right now? It might be time to go audit those RAG pipelines, secure those loading docs, and completely rethink your data trust models. Thanks so much for joining me on this explainer. Keep learning, and please stay secure out there.